This is the help video for the practice problems for the take-home practice quiz. In solving for a variable, always remember to grab and distribute. Collect like terms. There's a plus sign, not a minus. Get your variables to one side and numbers to the other. So taking a look at number 2, when you're working with fractions, your job is to create an equivalent expression. If you have a whole number, like 2w, you first must change it into a fraction. Once you have all fractions, then you can work to find your lowest common denominator, your LCD. Once you have your equivalent expression, then you simply isolate your variable. Taking a look at number 3, simplifying a radical. You want to go ahead and factor. I'm gonna run out of space, so I'm going to bring it up here. You want to take a look only at the leaves, so we're ignoring the branches. So we're only looking at the leaves. And here we have a pair of 2's. So a single 2 comes out, a pair of 3's, a single 3 comes out, 5 stays home. So your final answer is 6 root 5. Another way you can do this is called backwards division or upside down division. It looks like this. 2 goes in there 90 times, 2 goes in there 45, 5 goes in there 9 times, 3 and 3. You only work with the things on the outside of the backwards division, which will be your prime numbers. And again, a pair of 3's, a pair of 2's, single 5, 6 root 5 is your answer. We treat radicals the same way we treat variables. So take a look here. Do you see those are the same? So we would treat this as if it was 8x minus 2x, which of course would be 6x. So this would be 6 root 13. Now, if you had variant variables, the first thing you would have to do is simplify. For example, if you had 6 root 8 minus 5 root 2 minus 3 root 3. At first glance, it doesn't look like anything matches. But if you factor each thing, so the red, we can pull a pair of 2's out. 2 times 6, that's going to be 12 root 2. There's nothing to pull out here, so that'd be negative 5 root 2. And then minus 3 root 3. Now these two can collect. 12 minus 5 is 7 root 2 minus 3 root 3. And that's as far as you can go here. When it comes to simplifying radicals with multiplication or division, you follow this process, what I call innies, outies, simplify. Innies, outies, simplify. Step 1, we see if we can reduce our, what I call inside the radicals or innies, which we can, because 15 goes into 60 directly. So we end up with root 1 over square root of 4. There are no outies. You want to get rid of the radical on both top and bottom. Any radical times itself is just a number on the inside. Okay, you're not done here because root 4 is perfect. Square root of 4 is 2 over 4. Ultimately, you're going to get 1 over 2. Rationalizing the denominator here. Again, the goal is to get rid of the radical in the denominator. Multiply top and bottom by the same denominator. Any radical times itself is just the number on the inside. Now we check to see if we can reduce anything else, and we can't. So your final answer says find the perimeter. Notice that one side length is not given. So we're going to walk this around. Perimeter means to walk around, so we're going to add 14 plus 7 plus 8 plus 9 plus 16 and then we have this portion that we don't have, but if you look very carefully, we physically trace all the way across, and we can see that from here to here is 14. And if you go back from there to there is 8. So this red piece that we want is simply going to be 14 minus 8, which is of course 6. There's your missing side. And you simply add everything up. And we get 60 yards is our perimeter. Says the area of a rectangle is 6,916. The width is 76. What is the length? Let's start by drawing a picture. And we know area equals length times width. We are given the area is 6,916. We're given the width of the field is 76. It's asking what is the length. So you can see that this is a division problem. So we find that our length here is 91 meters. Down here, the perimeter of a rectangle. Again, always draw a picture of the storyline. The perimeter, which means when you walk it around, the perimeter is 346 centimeters. The length is 96 centimeters, and we're trying to find the width. Well, in this case, this is 96 as well, and we have another width here. So we can simply go 346 equals 2 times 96 plus 2 of our widths. It's 192 plus 2 widths. $154 equals 2 widths, and we get 77. Number 9. It says the length of a rectangle is 2 centimeters longer than its width. Longer than, it's a positive. So the length is 2 centimeters longer than the width. Here would be the width. The perimeter of the rectangle is 68, so you walk it around. That's going to be P equals 68. Find its length and width. So perimeter equals length plus width plus length plus width. 68 equals 2 plus W is our length, plus W, plus 2 plus W, plus W. Collect like terms. And solve. So we have found that our width is 16, which means our length is therefore going to be 18. Problem 10. It says the length of a rectangle is, it's an equal sign, 4 yards longer than its width. So that's 4 plus W. Once again, we're told the perimeter is 48. So we walk it around. P equals 48. Our goal is to find its area. And area, of course, is length times width. Always start with what you have, not with what you want. We have the perimeter, so that's what we're going to start with. So we plug in that for length, collect like terms. We have found our W is going to be 10. Which means our length is 14. come up here, length times width, that's 14 times 10. Area equals 140 yards squared.